Okay, hi everybody. We're gonna start right now our presentation. Thanks for the people at Houdini for each taking interest in coming to us and preparing a presentation with us for this. I'm Alejandro. I work at Gameloft, and I'm gonna be one of your presenters today. It's gonna be a quick set of 3 presentations. Okay, we're gonna tackle Houdini is a huge beast, like we have seen in the previous presentations. So we're gonna tackle the different things. Pascal is gonna be more on the generalist type of background, traditional sense. Houdini asset generation. Alexander Stukov is gonna be more on the tools-based zone of the software. And me, I'm gonna be tackling more of VFX. It's gonna be the mostly technical part. We're gonna leave it at last. Gameloft is a company that was founded in 1999, and since the beginning we have strived to have a AAA, the highest quality possible. Polish is usually our game. Okay, I'm gonna show you a trailer of the latest game that we released. We use Houdini for some of those things. Okay, we're gonna show during our talks how we use Houdini in those specific parts, and also to show you the quality that we are trying to aim.
We are here today to create a little chaos. Reach the zone and secure the designated area.
Roger that.
Playtime.
I understand. Copy that. Let's get to work, mates. You are in my sight. Activating cloak. Lock down! Shut down. Honor among all else. Shield goes up, you go down.
Double kill.
Molo. The only name you need to know. You're an agent now. Welcome to the team.
Okay, just to make it clear, this is aim for mobile. Okay, this is right now mobile. Our lowest device is actually on iOS. It's iPhone 5. So without further ado, I'm gonna present you our first speaker here, Pascal. He's gonna tackle the first section, procedural modeling techniques for high detail background textures, targeting always mobile devices. So Pascal, if you want to take the word right now.
Hi everyone, and thanks for coming. So my job on the game was to create a 360 environment map like this one here. I use mainly tree software for that, TerraGen for the skies, Houdini to process all the geometry, and Claris for the scene layout, the shading, and the rendering. So it was mostly the first time I've used Houdini, and the goal was to help me to create this kind of cities with a lot of greebles, very advanced pipe system. It's more about making the illusion of very detailed stuff. There are no streets and etc. And at the end, I've used it for everything. In fact, I mean about geometry, terrain, canyon, rocks. Mostly every geometry has been processed by Houdini at one point. So, oops. Wait. Wait. So yeah, as I told you, I started using Houdini last year, and I'm very happy that Gameloft gives me a bit of time to learn the basics, because yeah, it's another package. I wasn't used to procedural modeling at all, so it takes me a little bit of time to get used to it, and it's very fun. In fact, I create a lot of prototypes for helping me for the modeling task, like creating windows. I've also built a lot of parametric assets like bridge and greeble and favelas. I mean, stadium. It was pretty fun, and yeah, I've prepared two breakdown of 2 pieces of the background. So the first one is this mountain and favela things. Everything is done in Houdini. So since version 16, I guess, there is a height field editor now with all the tools you need to manage height field. You can blend noise, distortion, you can have erosion. So all the basics are covered. And of course, the cool thing is that you have also access to all the other modeling tools. So at one point, I want to try to flat the terrain, like there was some basement, but just for the height field. So I use a couple of nodes for that. You can just project height field on any arbitrary geometry, and you can create mask, and at the end I can create easily a very nice transition and flat the terrain like there is a small basement. One that works with one piece, of course, you can just expand that to the whole terrain. So that's thousands of small basement created randomly, and that's the projection of it on the terrain. So works pretty well. Another prototype I would like to add was some kind of electric pole system. Again, procedurally, I don't want to do that by hand. So I start again with a very small prototype, 2 poles and in few cables between them. I can then cycle between all the cables, resample, so adding more points, and deform the points with a parabolic equation. Looks complicated, it's not, it's very easy to do. There is no dynamics, nothing, it's very fast to create. And then I can just create tubes. Every cable has a different parabolic multiplier, so I've got a bit of different tension just because we can do it. Then you can apply that on a terrain completely and having control about the density and creating very crazy cable system. So that was the look of the terrain with the cable and the basement. So looks already pretty cool. Of course, the next element is the favela itself. Again, I'm using only expression and a channel referencing. It's basic Houdini stuff. Stacking models. There are a few tools very handy, like the find shortest path that lets you create pipes between 2 points. So, and of course, when the favela is done, I don't have one favela, so I have billions of them with lots of variation as I want. One small element I would like to add on the wall was to break a bit the sharpness of the wall without adding too much geometry either. And that's the little recipe I did. Was first remeshing, then smoothing the point, and adding a small noise on it. And at the end, I just create a Boolean intersection between the two models, and I get these eroded walls. It works for this model, of course, then I can apply it for the wall favelas. So for the trees, that's the only thing I wasn't able to do in Houdini because I didn't have the time. So I use a plugin from Blender called the Grove. It's very fun plugin to creating trees. It's more a simulation, live simulation than a traditional tree builder. So the structure of the trees are just branches, and then there is a point cloud created by Blender, and on the top of it there is an instancing of twigs. They have a very specific orientation, and I had to use Houdini again because I have to import that asset in Claris, and I had to recreate this instancing system with just a point cloud. So when exporting from Blender, you receive a triangle cloud. So in Houdini, I was easily able to recreate the right orientation. The process is just going through every triangle, at a point in the middle, create the normals, and create a second vector, thank you, to create the up vector, which is between the center and the third point of the triangle. So really easily, I get the right orientation. That was enough to recreate the instancing in Houdini, but Claris need an orient attribute, which I even don't know what is it. It's a quaternion, and so that's where having friends on the internet is very useful. It's just 2 lines of VEX code I have to add, and it creates the attributes I need. It makes sense when you read the line, but I will never find it myself. So that's the results, the expecting results with the right orientation of the twigs. And yeah, I want to recreate the system in Claris because then I can control the density of the leaves, the density of the size of the leaves at render time when I do my composition, which is very important with trees because you are just fighting with the anti-aliasing, and yeah, having a nice size, a good size is very hard. So why Claris? That's something pretty cool also. That's the complete mountains with the favelas and the trees. There are something like 60 billions of polygons in the viewport, and you can manage it and layout like it's a cube. It's a CPU viewport, so you don't need to have any graphic card. It's very nice tools to assemble all the mountains. And here I've got 1 mountain, but with the system I can create multiple of them during the night, and I have a lot of assets generated by Houdini. So the shading and the rendering is done in Claris. Any attribute you create in Houdini can be extracted in Claris, so you can extract any data you want. It's it works very well together. The second piece of model is this canyon thing, all done in Houdini 2. I'm mixing 3 modeling process: displacement, VDB, and 8 field. So VDB is voxels, classic displacement, and 8 field. So yeah, displacement, you can do that in any software, just pushing the point along the normals. Works, of course, very well when it's a sphere, but when you apply that kind of displacement on an object that has already a lot of details, you create a lot of artifacts and ugly geometry. Yeah, that's the way it works. But in Houdini, there is, that's the normals that are used to push the geometry. So the idea is to somehow tweak these normals to get a better result. So I came up with that solution, which is partially inspired by TerraGen, in fact. So I create a very over-smooth version of the model. It's a voxel model, so that's the reason I'm losing the details on the hair. It's smooth, and then I create normals on it, and I can transfer the normals from the smooth version on the iOS model. It gives a swing shading for the moment, but you see the normals are already much more well oriented. And so that's the old version of the normal, the new version of the normals. And now when I can apply very extreme displacement map without introducing any artifacts, things stay under control. That's another version, same model. It's using the new Manhattan noise, very cool to create rocky things. And this time it's the same process except that I store the smooth normal, and I recall the normals every time I want to stack a new displacement. So you can create very nice structure, keep the original shapes like in place, and it's a good way to create rocks, in fact. For the canyon, it's actually made with a collection of small columns, like here. So it's all start with a circle and a noise on it to get different shapes. Then I extrude them and I taper the bottom to get a bit of kind of pencil kind of look. Then I create a small point cloud and I copy stamp the column. So basically every column has a different shapes and different altitude. I can randomize every copy, and I get this kind of shape. I can then convert it into voxels using the VDB tools. In Houdini, it's very fast. And now you are in the voxels length, like a 3D code. And you can apply also procedural noise on voxels. So here I'm tweaking the density based on the altitude. So a lot of distortion of the bottom and mostly nothing on the top. And it can give a very nice initial shape. When dealing with voxel, you often have flying things, flying piece. And again, there is a tool in Houdini that lets you easily, you can easily select the biggest chunk of the voxels and just delete everything flying around. So for the bottom part, I do a mirror of the top part, and I project it on a height field this time. So it doesn't look very nice, but after a bit of tweaking and a distortion and all the goodies from the height field tools, you can have a nice terrain. You can apply erosion on it. And you can recombine everything together as VDB again. So now it's one voxels mesh combined. And once it's converted into polygons, I can go pick features from the erosion node. So here I just copy transferring the flow map from the erosion. Very handy to create for the shading or to create additional details like rock fields on this area. And at this time, I create my over smooth model, so I can add additional displacement on it, and I still get a very nice model, topology-wise. So after that, it's just a matter of pushing a bit the voxels, making much more voxel, much more resolution on the terrain, and again, I don't have one canyon. I think it was something like 10 minutes to process for the whole piece. So over the night, the morning, I can get like hundreds of different canyon. And again, I can place them and layout them in Claris. Here it's 500 million polygon. Doesn't matter. And it's easy to tweak and compose the whole background. So that's in game. You almost don't see the difference between the game level and the background. So yeah, we didn't try to make something hyper photorealistic, so it matched very well the levels. So that's the top view of the city. It's only a 4K image, and the HDR is faked. It's a RGB M system where the M is the luminance of the HDR to create this auto exposure thing. Voilà, that's it for my part.
And I think we shouldn't forget that all of this is only for a mobile game, so even if it's really high quality, it's still a mobile game, so yeah, really cool stuff. Sorry? Yeah, and all of this, like, as you see, just a reminder, it was done by one person, so modeling, texturing, lighting, rendering, all of it was done by Pascal, so it's pretty impressive. So for myself, I'm going to talk more about production-oriented tools. So it will be less pretty, sorry, but it's more about helping the artist and the production to simplify some tasks. The first tool I'm going to talk about is what I call the vegetation tool. Basically, just tools that allow really fast vertex color painting and editing on meshes, specifically foliage and plants, and to make them compatible with a wind shader. So I will just going to show you a video of how it should look. Okay, so this is in engine. As you can see, we have a bunch of plants, and they are all using our in-house wind shader. Our wind shader is a basic vertex animated shader, and all the vertex channels, so red, green, and blue, are masking different components of the animation. Just a quick overview of the shader. The red channel does like a big broad movement. Here you can see the vertex color on each plant. The green channel does a random offset on everything, and the blue channel does a really high frequency movement that you usually have on the extremities of the plants. So yeah. So first thing is why even make this tool in Houdini. Here you can see a bunch of plants I will receive and that I will have to process to make them compatible with the wind shader. And I wanted to make a quick prototype of an Houdini tool to make this process really easy. So, and before starting something in Houdini, one thing I will always do is do it by hand. So this is what I will show now. Every time I want to do something procedural, I will always do it by hand. So here you can see me doing it in max one time to get what exactly do I want to do. Here I'm trying to select by hand the extremities of the plants. Like I said, it's for the high frequency, slow movement, fast movement. And using the standard vertex color tools. Here I will do the red channel. And what I'm doing here is not really interesting. What's interesting is that I will do it 1 or 2 times to get the process and try to have a feel of how to do it procedurally. So how to get this, but in a procedural manner. And one thing is doing this by hand take approximately, I would say, between 5 and 10 minutes if you want to be really careful. And yeah. So let me show you the final thing. So this is the final tool. Those not really comfortable with Houdini, I can explain really quickly. On the left, you can see it's just the 3D viewport, so I can see which mesh I have loaded. On the middle is just the UI of the tool, and on the right is the network. So it's a really simple node network, but the tool is really fast to use, and to make was really fast. It was less than half a day to do, because if it was too long, there would be no point of doing this. You have really instant feedback on what you're doing, and it's all procedural. So if the mesh change, you keep everything. So it's really the main thing about this tool. Just about the UI I showed you, basically you can change the mesh you want to process, and you have different controls on the red, green, and blue channel separately, and a bunch of bonus features. And here a quick video of me using the tool. So you will see here I will just load the mesh, and I can like procedurally select the extremities of the plants, and I have some sliders to control the intensity, the spreading, and everything. And I have the same controls on every single channel. So here the red channel is just a gradient from top to bottom, and I have a nice curve I can just edit. And as you can see, everything is instant. So as an artist, I can really say this helped a lot, because if you have to do this one by one for each plant, it can take really long. So it's a simple tool, but it really helped a lot. And here I'm just masking the center of the plant procedurally, same thing. Okay. And same as before, here's a bunch of plants that were passed through Houdini to get their vertex color done, and the animation. So on the right, I'm showing again the graph, which is still really simple, and I'm going to talk about 2 things today. The blue channel, so how do I get the extremities, because I think it's an interesting thing, and how to get the normals, which is something really important when you are doing foliage on games. You want to have really nice normals. So first thing first, the blue channel, we'll just break it down step by step. So first thing, I just load the mesh, and now I have to think a way about how will I get the extremities procedurally. I have to create rules about this. So one way I went was just create a convex hull. There is a nice node in Houdini called convex hull. It will create a convex hull, and it's usually used for collision or stuff like this in games or even in CG. And once I have this mesh, this convex hull, I can just keep the point and color them. So I can color those points blue, and then I can use one of the most powerful features of Houdini, which is the attribute transfer. So I can just send this color towards the mesh using the position. And just by exposing some of the parameters of the attribute transfer, I can create really quickly a UI for an artist to use. So just like this, I can find the extremities procedurally. And the other thing I want to talk about is the normals. When you do foliage and plants, usually you want to have really smooth normal on the mesh. So same thing, just a little breakdown. Here I'm just loading the mesh. Here I'm displaying the normal of the mesh. As you can see, they are pointing in all the direction. And I want to create like smooth and kind of spheres normal. So first thing, I will just create a bounding sphere. So a bit like a bounding box, but it will be a sphere. And in Houdini, it's really easy to do. Just take a sphere and plug your mesh inside, and it will create a perfectly sized sphere. And I'm just, if you can see here, I'm just clipping the bottom. That way I don't have any normals pointing down. And then I'm adding normals to this sphere. Here you can see them. And same thing as before, I want to transfer those normals to the mesh. So using the same node, the attribute transfer, I can send those normals to my original mesh, which is really, really fast. And I don't think there is a faster way to do this than in Houdini, honestly. And since I'm in Houdini, now the tool is basically done. I can just add other stuff and just have fun and add new features really quickly. Since all our mesh already had some UVs, of course, for the diffuse, I just took those UVs and add a pack node. So now I have some light map UVs. So really simple stuff. Okay, now I'm going to talk about a second tool. This one is called a vertex heatmap tool. So what is this? It's a tool that creates pictures. So it outputs pictures, and it will create a picture that shows the vertex density of a mesh. And it will mainly be used by artists to optimize a map. So just a quick thing about the optimization process. So usually in a game, because I have to remind you, we are still in mobile and we are doing those games for high-end mobile, but sometimes we have to target really low-end devices when we want to have the smallest mesh buffer as possible. So we want to reduce the number of vertices. So when you optimize, usually you have a bunch of, this is my analysis of optimization, but you have three questions. First of all, what do you want to remove? Is it like materials ID, textures, simplifying shaders, or vertices? For our case, we know we wanted to remove vertices. Where do you want to remove them? And as an artist, it can be really hard to know where to remove stuff because it's hard to visualize, where are the highest density area and how much do you want to remove. And this stuff is more, I guess, a personal choice. Each people will do it differently. But what this tool does is that it will help the artist know where to start optimizing, so where to remove the stuff. So here is an example of the kind of images it will output. So let's say I have this mesh. It's just a part of a city, and let's say an artist say, okay, I have to optimize this part, but I don't know where to start. So what I can do is pass this geometry through the tool, and it will output something like this. So I can say, oh, you see the yellow highlighted area? Start optimizing this way. So it will help the artist. And let me show you, same as before, the tool. Really simple. So on the left, 3D view, same thing, and I can navigate in the 3D view, take some screenshot and send them to the artist. On the middle is the interface of the tool. So not a lot of things, just a color ramp, as you can see. I can load a mesh, and there is a scan size, basically a precision size. I will talk a bit more later about this. And on the right, you can see the graph. I think it's even simpler than the tool before, but same thing. I think it took half a day, something like this to do. So really quick tool to make and easy to use, and it's really useful during the production. So here, a quick video of the tool running. So the main control you have on this tool is what I call the grid size, basically. It will divide your scene or your mesh in multiple divisions, and the division with the highest vertex count will highlight, basically. So if you divide your mesh in like 2 big chunks, here you can see I will do it in 3 chunks, I think. So you can see, okay, which part here, you can see the middle part has the most vertex count. And the more smaller your division are, the more precision you have, basically, and the more fine data you have. And let's say, for example, I want to see where are the most, the highest vertex area here. I can also use this feature called section view, so I can isolate a part of a mesh. Sorry, on the video it's a bit laggy, but I promise it's a real time when you do it. I can move this section here, and I will here. Yep. So I'm going to check this area, and I want to see really what I need to optimize on this area. So here I will zoom in and lower even more the division size. Okay, and then I can, for example, take a screenshot of this, send it to the artist, and say to him, okay, you can optimize here if you want. Can be really helpful if you have like a lost mesh or something, because it can be hard to visualize. Okay. So the first thing is how to do it in Houdini. So even starting opening Houdini, you have to think about how you will show this stuff. So I'm just going to talk a bit about the theory of how to do it. So like let's stay in 2D for now. So first thing, you would just want to load a mesh. Sorry, the video will flicker every time, I think. Once you have your mesh, what you want to do is basically create a bunch of points that are uniformly distributed on your mesh. Here they are in sort of a grid fashion. What you will do after, for each one of those points, you want to scan around those points and count how many vertices there are. Here you can see, for example, the one on the top left count approximately 10 vertices around it. And what you do is you store each of those information into points. And when I say store, of course, if you know Houdini, when I say store, it's basically mean store it in an attribute. So once I have this information, I can just divide each of this number by the total number of vertices, and then I will have a normalized value. And once I have this normalized value that you can see here, I can just remap it from 0 to 1 and map it to a gradient. And here you have this. And then using the same as usual attribute transfer, I can transfer this color to my mesh. And here, sorry for the video again, but you can see on different 2D example, it works pretty fine. So yeah. So now I have this, like I have the theory of how I want to do it, how to do it in Houdini really quickly. So first thing, I have to load my mesh. Then I have to create the uniform points. So how to do it, I will use another node for that, but first of all, I need to create a bounding box. You will see why after. So I just create a bounding box using a bound node, or you can use a box node if you want. And then I can use the points from volume node, which is really cool. Basically, just take a volume and scatter a bunch of points inside, but in a really like uniform grid fashion. And you have one parameter, which is the distance between the point, and I can just take this parameter, expose it to an artist, and then I have this division size. Once I have this, I can just go through each point and use a VOP node, or you can do it in Vex too, I think. It's called just near point, and each of these points will find the nearest vertices here. Actually, in reality, it's done the other way around. Each vertices will go find the nearest sampling points. Okay. And here I'm just scattering a bunch of box, copying a bunch of box on those points to have some kind of voxel visualization, because it's easier for people to understand that way. So it doesn't affect anything, but just copying some boxes make it easier to visualize. And once I have this, I can just do the division and remapping and everything. Project this back to the mesh, and then I have this really cool thing. And some example of the image we actually use in production. So on the top, you see it's a top-down view of the map. I would just zoom on one part and send this to the artist. And the artist will start optimizing on this area. And actually, it was really useful because, like I said, for mobile, you want to be really optimized. So it really helped a lot the artist. And I think it made pretty cool images. So it can be, a reference to do different data visualization or even motion graphics, I guess. And a way to improve this tool would be really easy, would be to add support for material IDs. So you can have a material IDs heatmap, something like this. Or you can even add this in a Houdini engine, for example, integrated in engine, and have this visualization directly in your engine, like in Unity or Unreal. I guess it could be possible. So yeah, so that was my part, and now I'm going to give the mic to Alejandro. Yeah. Thank you.
All right, I want to try something here very quickly to see if this, because the videos are jumping too much. VLC was turned off. Okay, well. Okay, this is gonna be one of the technical side of this talk. At any point, if you guys want to know more, come to see me after, because I can get really deep. Maybe not everybody wants to deep dive on some things. Okay, it's mostly for VFX. Real-time shaders, preparing geometry with Houdini. We have so much control of what we want to do with the with attributes, and then after we can read them real time in shaders, okay? So we have here an example of what we needed to do. This is gameplay related. One of our characters in Modern Combat Versus, the characters have abilities, okay? One of them is a scan-based shockwave that he triggers. And each character that gets tagged by it, it forms this way. It kind of integrates, okay? It's kind of the player will have a hot visor type of augmented reality view of the enemy that got tagged. I'm gonna show you how it looks in game. This is the real-time implementation. Okay, this is a first test. I'm gonna show you guys. I did a first prototype on 3ds Max. Then we went on to Houdini. It was actually my first time that I went to, okay, let's try this with Houdini, and production time for doing these things went way down. This is how being tried out on many type of objects, on many. Actually, afterwards, this type of at the beginning it was for this character itself, and we ended up using it on many things, like loading screens. So while the character is loading, we will show first this lightweight triangulated character, while the real full HD character was loading. Okay, the process. First, we get an object. We try to have a uniform mesh around the whole character. We reduce and optimize, so we get this triangulated look. And then we have to store in the UVs of the character. This is because of the shader, okay? The shader is expecting custom data to be able to find the center at runtime, okay? We store this information on the UVs. I first did a 3D prototype. Was mostly on MaxScript. It works fine. I mean, it did this job. We will go and get a model. We will clone it. I will use Pro Optimizer on it. I was using just a default 3ds Max modifiers. And here on the left we see a tool. Okay, this is a tool that I wrote using MaxScript. It works fine. It's cool. All right, it does its job. The problem is every new feature that you want to do, it means writing a lot more code, a lot more library. That's where at some point we say, okay, how we can improve this for a full production, more procedural approach. Okay, that's where we go to Houdini. Same process, but it's mostly visual. You don't need to do mostly code. Same thing, we get the model. We do the uniformation. How we do uniformation? We use the VDB to polygons to VDB tools, like Pascal explained many times. We go back from VDB to polygons. You will have a uniformation. Okay. Then we use polyreduce. Polyreduce, by the way, that is now getting faster and faster every time. This is almost instant in our case. To have the triangulation. Here, it was so quick. This is something that Alex tried already in a couple of hours. He had the same thing that we did with the 3ds Max using the MaxScript. That took probably 3.5 days. And now we start having fun. Since we are there, it's all visual. It's like, okay, the mesh is not too uniform. So let's randomly pick some faces, put them in a group, apply a 3 divide on the group. That way we break, on some triangles, we break the monotony of the uniformity. I'll get a bit of water, sorry. This is probably the most technical thing I will say today regarding this tool. Okay, we can store the center of the face two ways. Either we store the center directly on the vertex attributes, or we store how much of the bitangent of the tangent and bitangent we're going to use at runtime. Why this? Is because we want to use it to skin characters. This is something that we didn't tackle on the first prototype, and it's like, okay, let's use Houdini to do what we did before and continue moving forward on it. A small visual video of what the vertex shader expects and how to work. So this is an example. We have the center stored directly. Each vertex knows what the center of the face it forms part of is. You can use it directly. And this is the red triangle to represent a skinned face, okay? In this case, the center, since the character will be moving with skin, the center will move. It's not in an absolute object space anymore. Here, what we store in our vertex attributes, we store how much of the tangent and the bitangent to use to find that center. There is a nice Houdini sub that is called the polyframe. With polyframe, you can handle a lot of the tangent bitangent complex math. Okay. If you're interested at some point, you can come to me and I will explain to you more about the how to use this sub to be able to store in the UV how much of the tangent bit I need to use to find a center of a triangle. If we do the same process to all the triangles, so we have this type of a triangulated effect. A trick to get the center of a face, no matter how you store it, either you store it using the tangent bit tangent way or the storing directly the value itself. We get the mesh, we break all the points using a fuse node, we collapse with expressions. Here's a trick. If you apply when you apply a primitive sub, you will have you will have transform tools on this one, okay? You can use the pivot center. When you type this, is what it means is use the center of the face itself. If you put a scale 0, all the points will collapse to 0. After that, you just have to transfer them back to the original mesh. It's the same mesh. You just, okay, this is for each vertex, this is the final center position that I want to use. The polyframe sub, this is something that I talked already. Come to me if you are interested on this. This is an overview of the tool. We have some of the, while we are doing, like we are getting the uniform meshing, we convert back to mesh, we poly reduce. We can quickly and easily start exposing parameters for this, okay? Adaptivity, seed offset, voxel size for how to convert from the object mesh to the voxel-based space, so on and so forth. It's potentially bashable. We didn't finally get onto this because it was me mostly using the tool. I will use it there locally. I will just load mesh after mesh. It will be really quick, but this is something that you could probably make use of. It could be, if it's integrated using Houdini engine, it could work directly in the engine, in your game engine itself. Sadly, we ourselves, we still haven't gotten there. It's been maybe 1 year, something that we're using Houdini, so we still have a lot to unleash on this. But we are getting there. We're very happy with what have been able to use to do until now. Okay, a single digital asset can do so many things, and the more time you spend on it, the easier it gets to expand. The most important thing: change the input, have the output straight away. We are thinking procedural in this case. Now, this is our final tool. This is something that I think you guys will find very interesting. Vertex destruction tool. There's a new thing, well, recently new, at least for us. Mike Lindon and Luis Cruz from Side Effects, they have been working on something called the game tools. Okay, it adds a shelf on the Houdini. It's called, one of the things we started using was the vertex animation texture shelf. Basically, for the destruction tool pipeline, you start Houdini, you click on the button there, and you can go home. You already have all you need to do free body baking, simulation baking to texture, fluids simulation baking to texture. It works out of the box. It's impressive, okay? Now, not really. We want to now adapt it just a bit for mobile game devices, okay? We want to aim mobile, but it was really easy to, it was a fun process actually. I'm gonna do an overview of how we did all of this. What is a vertex animation texture? It's a texture that contains animated mesh data on a texture of the texture. Instead of having a pixel color of a surface of a mesh, we can have this vertex in any time and space. It's at some position, okay? It looks like this. It looks very weird. It is because it is in a bounding box, a uniform bounding box, okay? I would like to show you what you can achieve with this. You can destroy buildings. The cool part is you change the texture, then you have another animation. You can set up Houdini to do many types of simulation, many types of things, and each new outcome, it will be a new texture. This is kind of how it works. Imagine a piano roll that is going for each row of the texture, and each row of the texture has where each fragment will be at that time. You can go crazy. You can go play it backwards, play it forward. You will have objects that form together, objects that destroy also. Okay. This is a technology we're using for an unannounced game. We cannot really talk about this just yet. But what we did is we took from the Modern Combat game, we took an asset and we tried something really cool. We said, okay, let's try this tool. There is a bridge there on the back. this bridge here in front. It's like we took that asset and we decided, let's put some of those nice explosions of the game, those nice missiles coming on, and then let's do it on a, you know, on a gray box type of thing, okay? Just to show, just for us also to test it. This is the animation itself. This is all with the same technology, doing a vertex texture animation, all right? The important thing is that it runs on mobile. And the textures are tiny. The textures are like 200 by 100. It's like the amount of pieces that you have is the number of columns, and the amount of frames is the number of rows on the texture. So just a quick overview of what we did to adapt it to mobile, to the mobile space. By default, the tools they come kind of tweaked for Unreal. Actually, the tool has even the shaders that you need to use in Unity or Unreal. It has everything. What it is, we remove all that swizzling. We're gonna leave it as default. We're gonna try to adapt it to our engine. We wrote the shaders themselves using the same as a base the shaders that were in the that comes with the game tool shelf and the game tools GitHub. Also, a really important page that you should guys take a look at if you want to take a look at this. Floating point texture, that's a no. Most devices do not run especially low end, do not read floating point textures, okay? So what we did is, all right, we don't need all that precision anyways. We are in a constrained bounding box. We need just a bit more precision on some parts, okay? In this case, we decided to encode the position data in 2 textures to have 16 bits instead of 8 bits of data. The pivot was on vertex color. That means that if you change the simulation, the pivot change of the mesh. We don't want that, because then it will change per simulation, okay? That's why we started on a texture. A new simulation comes with a new set of a pivot texture. That way we can really use the same mesh for many simulation types. This is okay. I will show you this. I showed you this before. This is how a texture looks, okay? What we are doing is, instead of storing in the R, the X position, in G, the Y position, and in blue, the Z position, what we do is we use pairs, all right? So in the red and green, we store the X position. In the blue and alpha, we store the Y position. And the red and green of another texture, we use the Z position. That way we increase the precision from 8 bits to 16 bits. If you guys are interested, it's a bit too technical, but just to let you know how we use the to encode a single float to 2 components, all right? Directly in Vex. You can do so many things in Vex that, yeah, we just do it directly in there. Why we encode it? Because of this. When you use 8-bit textures, especially for position, for big simulation, you start having jittery movement, okay? Maybe if the simulation would be in a more small constrained space, maybe, but this is a bridge, it's a big object. The difference is quite a lot. This is from something having very jittery movement to something that is fluid itself. Here's a comparison video, next to each other. You will see the one on the left is kind of having irregular movement. It goes vertically, it goes horizontally, while the one on the right is moving position-wise, okay? You might see a bit of jittering on the rotation, but that's because we are not interpolating the rotation itself. All right, so this is an overview of the texture we use. Position 16 bits, rotation only 1 texture, 8 bits then, and the pivot texture 8 bits works fine for our cases. Just a small consideration that you might need to have when you go from floating point to 8 bits, where every time you store a texture, the gamma correction kicks in, okay? So on your rendering part, you will have to move the gamma down. So when it applies the gamma, it gets back linear, okay? The alpha, par contra, it goes, it has to be handled with Vex by hand. Make sure also to change the point sampling. If you use the texture by itself, it has a weird filtering mode in there. I think it was min-max something, and it can break up the how the textures are put. Just a quick overview again. Close up, how the pieces are all jittering and how they go 16 bits. Still running on mobile, super fine. You can put objects and objects simulating this. I would like to also point something else. We have a really nice technical artist on our site, Fred Lecollier. Okay, he also tried to use the vertex animation, but in a different way. he used two textures, but one for a local animation and one for a void simulation animation, all right? And he actually did use the same idea of storing animation on textures, but for something completely different. He made a bunch of fishes moving together. He also, on his shader, he makes a, when the camera goes close to a fish, the fish tries to go to the character, go back. Crowds storing, crowds animation storing in texture too. Medusa, this is very interesting. What he does is the tip of the Medusa stores one part of the animation. The tail of the Medusa stores another one. So the animation is kind of, how do you say, delayed. So while one piece of the Medusa is at one position, the other one is a few frames back. That's what gives this, this is worth a full talk by itself, okay? So maybe at some point in the future we might take a look at that. All right, this is about it. This is the summary. We have seen impressive backgrounds with a one-man army, crazy techniques to create the super high detail backgrounds. We have production tools that accelerate the optimization and creation process for the vegetation and a level construction environment. Also a really specific effects tools and how to prepare geometry for this. If you guys have any questions at any of this, or if you want to know more information,